Hello engineers. Today we'll discuss the substation equipment layout. The substation equipment layout, what it means? It means the physical arrangements of the components of the substation which enables it to operate safely, reliably and efficiently. A good layout minimizes the faults, allows easy maintenance and ensures proper clearances. Now we'll see first in the substation. It is incoming line bay. In this incoming bay, the transmission line enters to the substation. As soon as it enters to the substation, then the equipments are arranged in the bay accordingly, sequentially. First comes your lightning arrestor. Then comes your wave trap. In case of 132 by 33 substation, it is used for carrier communication. Then capacity voltage transformer. Then comes isolator or disconnector. Then comes circuit breaker or fault interruption and current transformer. These equipments are sequentially arranged like this. Then second one, the busbar section. It is the central part of the substation which collects and distributes power. All the power coming to the substation enters to the busbar and it is distributed through the busbar. There are different types of busbar layouts. One is your single busbar system and double busbar system. Then comes main and transfer bus system. Then comes ring bus system. And then comes breaker and half skip. Above the five layouts, which one will be selected? It is depending upon the reliability and cost. And you will discuss more thoroughly about the busbar layouts afterwards. But you can now overlook the pictorial information for the busbar layouts. It is the single busbar system. Here the circuit breaker coming incomer 1, incomer 2 and incomer 3 through bus circuit breaker. The connecting to the busbar. Again from the busbar there is isolator, circuit breaker, sequentially these are arranged through circuit breaker. So here this is the double busbar system. This is the double busbar system. Here is the main and transfer busbar system. Main and transfer busbar system. And this is the ring busbar system. And it is one fifth one is your breaker and a half skip. Here the transfer circuit breaker is connected here. These are the feeder 1, feeder 2, feeder 3, feeder 4 like this. This is the breaker and a half skip. Then comes our transformer bay. In the transformer bay, the transformer is located. It transforms the transmission voltage to the distribution level. It includes the equipment as given below. First, power transformer, then surge arrestor, then lighting purpose, and the current transformer and potential transformers, isolators, and circuit breakers. This is about the transformer bay. Then we'll consider the outgoing feeder bay. It supplies power to the distribution feeder. After the voltage transformed to the distribution level, it is transferred to the distribution feeders through isolator, then circuit breaker, current transformer, potential transformer, then lighting arrestor. Then another section is a control room. The control room houses the protection panels, control panels, SCADA system, battery and charger. And another section, one of the important and vital section, that is called earthing system. It consists of ground grid for the safety, and all equipments are connected to the earth mat. Now we'll overlook some of the typical layout arrangements. Here is the case of 132 by 33 kV substation. It is the 3D view. It is the 3D view. You see, this is your line bay. This is busbar section. This is transformer bay and outgoing feeders. This is a typical single line diagram for the 132 by 33 kV substation. As I have told, sequentially the components are arranged like this. This is the transformer. And this is the 33 kV busbar, and these are the feeders are connected like this. The components are connected sequentially. This is the, then it is given for layout plan for 33 by 11 kV substation. You see, this is the single line diagram for two incomers, the two incomer, and this is the bus coupler. Two transformers are there, and the components are arranged sequentially. So these are the layout plan of a 33 by 11 kV substation. Then we discuss the types of substation layout. One is your air insulated substation, another is gas insulated substation. This is the air insulated substations, as you see in the outdoor substations. So this is the 3D view for AIS substation. This is gas insulated substation. FH6 gas, sulfur hexafluoride gas, is used for insulation and so these are the CB circuit breaker, potential transformer, and surge arrestor. These are the single line diagram for the gas insulated substation. This is for 132 by 33 kV substation. Let's see. Single line diagram. This is the Busbars section. This is the line way. This is incoming line. This is the transformer way. Transformer is there. So these are the substation layout for GIS substation, gas insulated substation. Later on, we'll discuss more about these substations. Whatever may be the layout, we will always give importance or our attention for electrical clearance. What is the clearance? What is the phase-to-phase clearance? What is the phase-to-ground spacing? It must be followed as per the IEC, Indian International Standard and Indian Standard. And must be easily accessible for maintenance and operation. During the maintenance, the components should be easily accessible. And safety will be prioritized for the substation. Fire separation between the transformers should be properly maintained. Proper fencing and interlocks should be operative. And environmental factors, wind, pollution and temperature, seismic condition, these are to be attended to during the substation layout design. Space optimization. For compact layout, GIS substation is preferred over conventional air insulated substation. So these are the things we have to take care of the things. In our next class, we'll discuss another topic. For today, this much. Thank you.